All right, so Joel was invited to give a talk at a DevOps D-Day in Marseille last week as a Thursday. So the event is in Marseille, France, in the Orange Velodrome soccer stadium, and so they will have news in July 2019. But last week they had to present about Kiali and Istio in the name of Red Hat, and he did a fun demonstration with based on like a soccer simulation. I actually didn't see the demo myself, but asked Joel if he was keen on doing it again, and since sharing is caring, I wanted to invite you as well for the demo. So Joel, I guess you can get started.
Yes, sure. So first, excuse me if I say football instead of soccer. And I'm going to share my screen then. Okay, so you get it?
Yes. Yep. Yes.
Okay, so this was the presentation that I did at the DevOps Day. I'm going quickly on the slides that talk about Istio because obviously I think you know already that, but I explained briefly what is Istio. I was with a co-speaker, I was not alone. We explained what's Istio, the sidecar proxy, some concepts about the different objects, the gateway, the virtual service. Slide about observability. Kiali, of course, we introduced briefly Kiali, and then we started with the demo. So it's a football game, football simulation with AIs, and basically everything is a microservice here. So the graphical interface itself is a virtual service. Then there is a service called the Stadium, another service for the ball, and services for local AIs and visitor AIs. And all these services are going to be deployed. And what is interesting to show is, for instance, and this is the example that we took, if we introduce a new ball, we will see that we can put some Istio rules in play to demonstrate different things. So excuse me, but it's the slides are in French. I did not translate them. The talk was in French, but anyway, I'm not going to show the slide a lot, but instead I'm going to show. So here, this is what I have. Kiali with at the moment just the UI microservice that is deployed, and on the left. On the right, yeah, on the left there's Kiali. On the right there is the UI and the game that will take place in this window. So the first thing is to deploy the ball and the stadium. Oops. Going to do that, and let's see what happens here. So here we got the stadium. The ball is on the upper left corner. If I click start game, it should soon go at the middle here. And in Kiali, we show the different microservices that appear. What is interesting here is to activate traffic animation. It's spread here. And also request person per total, I think, is an interesting edge to show. Why does it work? Okay, I don't know. Something's broken. Okay, the demo effect. Okay, I don't know why. Anyway, I continue. So at the moment, yeah, then I have to introduce some players. So let's make the player enter in the game. And so I deployed 2 microservices, which is one for the local player and one for the visitor players. And both of them are scaled with two instances, 2 replicas. So we've got 2 across 2 players. Okay, so I get the percentages now. And we show already, we can see, even if we haven't introduced any Istio rule, we get all the telemetry from Istio. So of course you already know that. And the graph is being animated. So at that point, it's interesting to just focus like on a single node, like the AI visitors microservice. And we see that it's sending requests periodically to the UI because it's basically requesting display. So it's that in the game loop. So there's like a game loop. It's refreshed every, I think it was 100 milliseconds. So at every frame of the game loop, it sends a refresh request to the UI. And also it's sending requests to the ball because it's trying to interact with the ball and trying to see where's the ball and if it can shoot the ball. Then, sorry, I don't see the chat messages. If there's anything to, I'm going to read at the end the chat message. So then we're gonna put a second ball, and this is going to be a problem, of course, for the players. You can guess, because we're going to have 2 balls, which is the same service but a different deployment version for that service. So I've got the white ball is V1, and soon we've got the pink ball here that I put on the center is V2. And here, what we can see is that the players are kind of hesitating between the 2 balls. And so what happens behind the scene is that, so this is the diagram I show here, is that the incoming request to the Kubernetes service is load balanced by Kubernetes to any of the pods. So here for the ball, we have 2 pods, and that's a 50-50 load balancing. And every time the players try to get the position of the ball, it gets the position of the first ball and then of the second ball. So of course he cannot decide at the end where to go. So they are hesitating. And of course, Istio will help here to have something better. So we have like 22% and 26%, and it will soon be the same numbers, I guess. Well, 24 and 24. So we've got this illustrated perfectly in Kiali. And we are going to set a destination rule that you can see here to identify the 2 versions of the ball, and a virtual service for 75 and 50 and 25%. So this is waiting. So the destination rule, it doesn't do anything, and the weights. If we see very quickly, we can see that the rule is applied almost immediately, and they're starting to play mostly with the white ball, but we see that they're still kind of hesitating. They still have like inconsistent behavior with because there's still the 25% of requests that are going to the ping ball. And in Kiali, we see the numbers growing for V1 and lowering for the V2. So next step. So yeah, some explanation here is that the request is coming to the Kubernetes service. So the slide is not extremely accurate because Istio virtual service is not like something that actually receives the request. The request is actually sent to any of the pods through the Kubernetes load balancing, reaching the Envoy proxy, and then the virtual service is checked, and eventually the request gets rerouted to another pod, and this is where we can see that the load balancing is 75% on some pods for version 1 and 25 for version 2. Now we're going to put new players. So I have Messi and Mbappe. They are much better players. They are going to take the ball from the other players quite quickly, you will see. Here we go. So Messi here is in orange and is playing with the yellow team, and Mbappe is the light blue, playing with the other blue team. So they're subject to the same rules as the others. They are kind of hesitating between the two balls. And now what we are going to do is having two games inside a game. Like so we want to have Messi and Mbappe playing with the ping ball and the other one playing with the white ball. So this is, we cannot see very well here, but this is the virtual service that we are going to apply, and which is basically a match by label from the source labels. So I close the window. Oh, sorry. Kill the window. So, okay, so okay, I got my game again. So I'm going to introduce that new virtual service. And quickly we are going to see, that these two ones are playing together with the ping ball, and all the others are playing with the white ball. So we have two games inside the game. This is illustrated with this diagram when we see that because the request is from something labeled version 1, and then when it comes to the virtual service, it's just doing the match, and the load balancing is performed only with the pods that match the label. Now we are going to first reset. I'm going to remove Mbappe and Messi, and delete the virtual service too. So we are going again with the state where they are hesitating between the two balls, and I'm going to introduce what I call a burst ball with traffic shadowing. So I'm putting a virtual service mirrored, like I have. I don't know if you can see. I have here my role defined. So all the players are going to to play with the ball v1, and the request will be sent to ball v2. And what I want to show here, so it's like if we are introducing, let's say we are deploying a new version of our service, and we want to check before deploying in production if it's behaving well. So the new service is the ping ball. And what we can see is that the players are playing only with the white ball because of shadowing. So they are sending the requests that they send to the ball are redirected to the white ball only, but they are duplicated to the ping ball. And but the players only receive the response from the white ball. So they don't care about the other one. And this is very interesting to show Kiali here, because Kiali perfectly shows, well, I think it's very nicely shows what happens with traffic shadowing. We can see here that all the traffic is going from the AI perspective. All the traffic is going to the V1, but and we have that gray arrow to the V2 showing there's no traffic. But on the other hand, we can see that the health of V2 is not good. And we can see that we have like 22% of errors. And this is because from AI perspective, from this service perspective, there's no request sent to ball V2. But if I double click on ball V2, for the perspective of the ball, we have request incoming. So this is a subtlety of source reporting versus destination reporting of Istio telemetry that allows us to show the traffic shadowing in action. Next step was to introduce circuit breaking. So here I will consider like I want to put in production my V2, so I'm going to delete the mirror mode. So at this moment, I have players able to go either to the white or to the ping ball, and I can see here the traffic is coming, and I have this arrow that is red because I have a lot of errors. So just to be something that I didn't say is that the errors are programmed in my microservice of this deployment. Like I explicitly said that I wanted to have like 20 or 30% of the incoming request that ends in a 500 HTTP code error. So this is programmed. And now what I want to introduce is the outlier detection. So circuit breaker via outlier detection. So this is a destination rule. And we will see that very quickly right now, they start ignoring the ping ball because it has been circuit broken. We are going to see quite soon that the number of requests here is being bigger on the V1 and is lowering on this one. And also one interesting thing to see, if I click on V2 here, here on the application, the health, we can see, I did not expect that. Normally the envoy health should be 1 versus 2 because it shows open circuit breaker. I don't know why it's not like this now. Okay, something weird, but Normally it should be circuit breaker. Anyway, this worked the last time I showed it. So basically, I think it's all for that demo. There's probably other kind of Istio features that we could demonstrate too, but I didn't have time to show more. Okay, so I stopped sharing my screen.
Okay, thanks. Let's stop the recording. If there are questions, we can